In the last video, we introduced the two conditions for any two figures to be similar. And one of them is the corresponding angles must be congruent. And the second one is the corresponding sides are proportional. In this video, we are going to look at three examples. And in the first example, we are going to tell if the statement is right or wrong. And the first one, two squares are always similar. And if you draw two squares, it will be like this. And we know all the four angles of a square are equal to 90 degrees. And all the four sides of a square are congruent to each other. So if you say this side over this side is 2 over 1, then this side over this side is 2 over 1, and this side over this side is 2 over 1, and this side over this side is also equal to 2 over 1. Therefore, the corresponding angles are congruent, and the corresponding sides are proportional or have the same ratio. The same thing goes to the equilateral triangles, actually. You can say any two equilateral triangles are similar. So the first one is right. And the second one, two isosceles triangles are always similar. For isosceles triangle, we know two sides are congruent to each other. But we don't know if the corresponding sides are proportional or if the corresponding angles are congruent, because the two triangles may be in this way, and this is one of the isosceles triangles with these two sides congruent, and this is the second isosceles triangles with these two sides congruent. But as you can tell, these two triangles here, they are not similar, so this one is wrong. And the third one, if all four pairs of corresponding angles of two parallelograms are congruent, then the parallelograms must be similar. And okay, so let's draw one of the parallelograms. Could be like this. And if I keep all of the four angles and I try to elongate the parallelogram to these two directions, basically the horizontal direction, then another parallelogram may be like this. And we can make sure that here this angle is equal to this one, and this angle is equal to this one, this angle is equal to this one, and the last angle here is equal to this one. But the sides here are not proportional. And as we can imagine here, we can make sure this side over this side here is equal to 2 over 1. And maybe this side over this side is equal to 1. Now, these two sides may be congruent. And therefore, the sides here are not proportional within the two parallelograms. So they may not be similar. They could be. So this one, if you say must be similar, this is wrong. And the second example is regarding the scale factor. This question here, the diagram is given. Now we have two similar trapezoids, and the scale factor is 2. And we are given that AD is a 4, C prime D prime. Here, this is 2. And angle B is a 50 degree. And here we want to find A prime D prime. As you can tell, AD and A prime D prime are corresponding sides, and therefore the ratio is 2. Since AD is a 4, A prime D prime is 2. And the CD here, the side CD is corresponding to C prime D prime, so this one is 2 times 2, that is equal to 4. And we want to find the measure of angle A prime, so this is A prime. Alright, we are given that angle B is 50 degree, and we know that A prime is definitely not corresponding to B. But we know that since they are trapezoids, therefore we know AD is parallel to BC. And angle A and angle B here are same side interior angles. And we know if lines are parallel, then the same side interior angles are supplementary. Therefore, angle A is equal to 180 subtract 50, and that is equal to 130. And we have angle A is congruent to angle A prime, and therefore measure of angle A prime is equal to 130. And in example 3 here, there's no diagram, and it's still regarding the scale factor. So here we are given two similar pentagons. And we know if you see this expression, all the corresponding vertices are in the same order. So we can write the corresponding sides and angles for part 1 here. CE, we know CE is here, and that is corresponding to, because C is at the 3rd place for A, B, C, D, E, so that is corresponding to RT. So this is corresponding to RT. And the PQ, this is a PQ, that is corresponding to AB. And angle D, this is angle D, that is corresponding to angle S. And angle Q, this is angle Q, that is corresponding to angle B. And part 2 here, AB over PQ is 1/3. And from this expression, we can tell AB is corresponding to PQ. And therefore, 1/3 is the scale factor of these two pentagons. And here we are given ST is 12. We want to find the length of DE. We can also tell DE and ST, they are corresponding sides, and therefore their ratio is also equal to 1/3. So DE over ST is equal to 1/3. But you need to be careful here. If you put ST over DE, that should be equal to 3. Okay, just need to be careful on this point. So DE is equal to 1/3 times ST. That is equal to 1/3 times 12 is equal to 4. Okay, these are the 3 examples. Thank you for watching. I will see you next time.